Hello everyone. Today let's solve the problem number 39 combination sum. Right. So we are given. So let me read out the question aloud. So let's try to understand the question first. So we are given an array of distinct integers. You can clearly see here. All the numbers are distinct right here. So we are given an array of distinct integer candidates and target integer as well. See here. Target integer. We have been given target sum. Right. So we need to find all the unique combinations where the chosen numbers sum exactly to the target, right? Where the chosen numbers sum exactly to the target. So, right, this is very important. Means see here, 2 to 3 will sum up to 7. The 7 individual number, this will also be equivalent to 7. So these are the two things that we need to return here, right? So we are given an array of distinct integers candidates and a target integer. All we need to find here is this one. All the unique combinations where the chosen numbers sum exactly to the target, right? So we can use each number unlimited times in a combination. So we can just make use of this number itself. Individual number means 2 itself, any number of times. So this will not lead to alone will not lead to 7, right? So it will be 2 plus 2 plus 2 plus 2. It will be even every time, not the odd, right? Same thing goes with this one, 3 as well, and we can just go with a combination of any numbers as well, right? Any numbers as well. But here see, we have got 2 to 3, and we can get 3 to 2 as well, or 2 3 2. So that combination we have to return only once. Means if the numbers that is present in the array exactly once, the numbers has to be present in the array exactly once, the combination of numbers, right? So that has to be present exactly once. Just remember that, right? So order saying, so order, it can be of any order, it can be of any order, but it should be only once, right? So we cannot give here 3 to 2 or 2 3 2, right? So that we have to keep in mind, right? So order of the numbers in a combination does not matter, but the frequency of element must be unique for each combination. But the frequency of the elements must be unique for each combination. That's what I said, right? So here they have strictly mentioned or clearly mentioned here 2 and 3 are the candidates, and 2 plus 2 plus 3, this one will lead to 7. We have to note that 2 can be used multiple times, and 7 is also a candidate, and 7 equals 7. So that's what I said here. See here, we have got 2 3 5 and target is 8, right? So we can just make use of the 2 4 times, right? So that will lead to 8. That is one thing. And we can just go with 3 twice and 2 once, right? So 3 3 2, that is also one combination, I think, but 2 double 3, order doesn't matter here. And one more thing, 3 once and 5 once, or 5 once and 3 once, right? So this will also lead to 8, 3 comma 5. So these are the things that we need to return here. This is fine. And the final one is we have only one number, and the target we have been given 1 here. So this is even 2, right? So even if it is once, this will start from 2 itself, right? So target cannot be 1 at all, at any cost. Sorry, at any cost, we cannot, this will not be equivalent to the target, right? So any number from the candidates will not be equivalent to the target. So at that time we have to return empty array, right? Empty array. This, just keep this in mind, right? So I hope the question part is completely clear. They have given us wonderful example just for the sake of understanding. Right, so now we are done with the question part. So let's do one thing. Let's move on with the approach part. So I'll be considering the first example itself for the approach. Right, first thing I want to tell you here is we will be going with a backtracking approach. Right, so just keep this in mind. We will be going with a backtrack approach. Right, just keep this in mind. So we'll be considering the first example. I'll be considering the first example, the same example, right? First, what we will do, we will start from the candidate 2. First, this one, we have the number 2, right? So this one will be candidate, will be starting from the first candidate 2. So we will keep adding 2 until the sum exceeds target, right? So this one will be 2 plus 2 plus 2 plus 2. So now sum exceeds the target, right? So now sum exceeds the target. When we give 4 times 2, sum exceeds the target, right? So if we reach the 7, then we will store 2 to 3. Here we cannot reach, right? So what we will do, we will ignore this one, right? So uh, next we will consider 3, right? So this will be twice the 2, basically twice the 2, then we will be considering 3. right? So this will reach 7. So we will store this combination. So we will be storing this combination, anything in the result. Basically, I'll just consider result here res for now. So then we try skipping 2. So we have went with the 2. We have tried all the combination, then we will skip the 2, right? So now we will be going with a 3, only 3. So as we are going with a this one backtracking, so this will be 3 plus 3 6, and again we will give 3 because we haven't reached the target. So this is again greater than the target, so we will stop here. So this combination is again not possible. This is similar to this one, right? So this is not possible, right? So now what we will do, uh, yeah, so now what we will do, from directly 3 it is not possible. So if we can go with the this one, 3 and 2, right? So 3 comma 2 comma 2, but here see the frequency should be same. 2 2 and 3 we have already considered here in this case, so we will not be considering 3 comma 2 comma 2 as well with the other numbers. We can either go with a 3 or this one 6 or 7, right? So with 3 comma 2 comma 2, so we'll not be considering because the frequency of the numbers here already it is there, 2 twice and 3 once, right? So we'll not be considering this one, right? So now what we will do, we will try with the 6 basically. 6 6 twice. So what we'll do, we'll try this one, 6 and 6 twice, because we have to go until it reaches the it is above the target, right? So 6 plus 6 will give us 12. So this is not possible, right? The combination of 6 is not possible, and the combination with any number, 6 plus 2 will lead to 8, which is greater. 6 plus 3 will give us 9, which is greater, and 6 plus 7 will also be greater. So we will not be considering 6 with any number, right? So this one also will not be considering, right? So finally we will come to the part 7. 7 is directly equivalent to this one, 7, target 7, right? So we will be considering this one. 7 will be directly equivalent to 7. So this one also will be considering. So now we have got two combinations basically, 2 2 3 and 7, right? So 2 2 3 and 7, right? So 7 we will check with any other numbers. 7 and 2, it exceeds the target. 7 and 3, it also exceeds the target. And 7 and 6, this also exceeds the target. And 7 again we cannot give because 7 is already equivalent to 7, and again considering 7 will give us 7 plus 7 14. That is also not possible. So these two matches, right? This is equivalent to the target and this is equivalent to the target, right? So 2 plus 2 nothing but 4, 4 plus 3 7. And this order also you can give any one order, any one's frequency of the elements within the array has to be same, right? So this one, either you can consider this one as well, 3 2 2. But let's go with the first one. We got this one, right? 2 2 3. Well, let's consider this one itself, and 7, right? So now we have these two combinations, right? Let's return these two, 2 2 3 and 7. So the output that we got here is 2 2 3 and 7, which is equivalent to the output that they have mentioned for the example 1 within the question, right? You can do the same thing. You can means you can try to implement the same thing for the example 2 as well. And example 3 is very simple one because you have only one element, and that will not sum up to the target anyhow. So you have to return the empty array, right? So I insist you to try out or implement the same thing, this one, the approach that we considered for the example 2, or try to articulate the same thing for the example 2 as well, right? So we are done with the approach, but I hope this one is completely clear, man. As we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be 2 to the power of t. So overall time complexity would be 2 to the power of t. So in the worst case, each recursive call branches into two possibilities. Either we can go with the pick or we can go with the skip accordingly with the approach, right? So where t is nothing but the target value, right? So overall time complexity would lead to big O of 2 to the power of t, right? So this will be the time complexity. So what would be the space complexity then? So the space complexity would be big O of t. So I'll consider this one small t itself here as well. This is fine. So big of t. So why it is big of t here? So we are making use of the recursion as we are going with the backtracking, right? Backtracking obviously uses the recursion. So here maximum recursion depth is proportional to the target when using smallest candidate repeatedly. So this will lead to the space complexity of big of t. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 2 to the power of t and big of t respectively, right? So let me delete this one entirely. Yeah. So we are done with the coding. This one complexities part. So as we are completely familiar with the approach and the complexity, we are good to write the code. Let's start writing the code. First thing, we have to store all the valid combinations. For that one, we'll be making use of the list man. So this one will be list integer. This is fine. Yep. This one will be result equals new array list. This one. This is fine. We are storing all the valid combinations, right? So now let's go with the backtracking. So let's do one thing. Let's make use of the helper method backtrack, and then we can implement the same thing within the main method, right? Or the combination sum method, right? So I'll just go with a private void here backtrack, which consists of the parameter c here. Also we have target, also we have index, also we need index. I'll just go with idx. Also this will be list of integer path, and also this will be let me go with one thing. This one will be list list this one will be integer, right? So this one is fine. Result. So this is fine. So now let's move on with the coding part here. So if target is equivalent to the 0, then we have found a valid combination and then we have to store it, right? So here this one target equals 0, then we have found the valid combination and then we have to store it and we have to stop exploring further. Let's see the storing option. So let's add this one to the result first. This will be new array list. Array list, this is fine. So let's pass the path here. This is fine. Next step is let's stop exploring further. Means we don't have to return anything here, right? So this is fine. We are going with target equivalent to 0, target less than 0, right? So these two things. When the target is less than 0, then we don't have to return anything, right? So means if sum exceeds the target, that is invalid path, right? So here if target less than 0, then we have to wait, we don't have to return anything. Finally, let's iterate from the current index, right? Let's iterate from the current index onwards to avoid the duplicates. To avoid the duplicates, let me go with the for loop here. This one will be I equals idx I less than c dot length I plus plus. This is fine within the for loop. Let's choose the current candidate month. So this one will be path dot add of c of I. So this is also fine. Now let's go with the recursion here. Uh, this will be backtrack c comma target. So target minus iterated value of the c. This one will be I comma path comma a result. So this is fine. The final step here would be we have to undo the choice. Means we have to go with the backtrack step. So this one undo the choice means here I'll just go with path dot remove path dot size minus 1. So this is fine. Yep. We are done with the backtrack helper method, right? So now let's implement the same. We have to go with the backtracking, right? So let's implement the same within the main method. So I'll just go with here. We backtrack that. So I'll just go with this one individual candidate we are considering, right? So this one will be, oh sorry, let me make this one capital I. This is fine. Now let me pass the candidate here. This is fine. Oh, candidates itself, sorry, not candidate. This is fine. We have to go with the target as well. Within the backtrack method target as well, we have to start backtracking from the zero, right? So this is fine. Mm, we have to consider new array list as well. So this one will be array list. So this is fine as well. Final one is result, right? We are just starting the DFS from index 0. Finally, we have to return the final list of combinations. Nothing but here I'll just go with a return result, right? So I'll just format the code once and let me hit the run button, man. Yeah, now you can clearly see here the sample test cases are getting passed. Means the code works absolutely correct. For the examples that they have given, for the sample test cases that they have given here, let me hit the submit button. I hope it works for all the test cases, man. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I hope whatever the code that we have written works correctly for all the test cases, right? So now I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.